markers. Okay, the last time round, we were looking at a set of questions. Okay, so last time round I assigned to you to complete in class these questions. I hope you have really completed them at home. Okay, is there any particular one that you'd like to ask or clarify before I sum up this section first? 3D. Okay, 3D. Anything else that you'd like to raise? 2D. 2E.
And D.
And D. Okay. 3.
5.
B. Okay.
5E.
5E. Anything else? 5. D. Okay.
5C.
6.
5C. No, 5.
5C. Okay. Anything else? Huh? Okay, so let's go through them. Okay, then question 2D. Okay, for question 2D, given this y equals to sin x over 1 plus 2x minus x squared, you don't have a choice other than to do quotient rule. So we keep the bottom, differentiate the top. Sin x itself is all together, so differentiating sine we will get cosine. Minus away, keeping the top, differentiate the bottom, okay, and then bottom square. Right? And then we can proceed with simplifying it. Okay, actually there isn't much to simplify. You can just keep it this way. It is good enough already. Okay? Yeah. Any questions? Any concerns? Can now? You can just give your answer like that. Or did the textbook express it in a different manner? Factorize out the? 2. Oh yeah, I think you can. That is really not that important. Okay, I just want to make sure that we know how to use our quotient rule. Okay? Then 2D, okay, 2E. This is the one where I did notice some presentation concerns, okay, when I walked around that day. This is Z in terms of theta. So when we differentiate it, how we present it is that we're looking for dz over d theta. Okay, please don't stick with your dy over dx. Okay, do contextualize it or adapt according to context. We're looking at z in terms of theta, so we should be getting this notation. Okay. One important thing is that this 2.3, right, the power itself has a base of 2 theta plus 3. Okay, so the base is this one over here. It is not the same as having it written like this. Okay, they do mean different things. This one has brackets. In this case, the base is the entire sine function, whereas this 2.3's base is actually just the 2 theta plus 3. Okay, so in order to differentiate this, we will start off with differentiating the outer one, which is the sine. The sine comes first, and differentiating sine will give us cosine. The angle maintains the same, and the angle is actually 2 theta plus 3 to the power of 2.3. Okay, if you feel that you might get lost around things, okay, especially when things get complicated along the way, you may wish to put extra brackets just to remind yourself that it is sine the entire thing here. Okay, so we have cosine of this, then we need to differentiate the inside, that means the angle itself, and then we have to apply our power rule. So let me just put brackets around this to show that I'm going to next multiply by 2.3, 2 theta plus 3, power minus 1, okay? And then the inside here, I need to actually differentiate again. That is actually a 2. Okay, so this part is the differentiation of your 2 theta plus 3 to the power of 2.3. Okay? And then we could simplify it. 2.3 times 2 will give us a 4.6. You may want to put the 2 theta plus 3, 1.3 at the front, okay, followed by your cosine. Okay, so that will be the derivative of this question. While we are on this note, I also want to just take this opportunity to show what if we are trying to differentiate this. Okay, so maybe let it be y equals to sine 2 theta plus 3 and the whole thing power instead. How will the derivative differ? Okay, so in this case, dy over d theta will be, we bring down the power because the power is now the one at the outside. So bring down the power, okay, then your power minus 1. So power rule applies first. Okay, then we go inside, which is the sine function where we need to differentiate, and sine function upon differentiation is cosine, angle remains the same. Okay, and now that we have tackled the sine already, we still need to differentiate further the angle itself. That will be another 2 itself, because 2 theta plus 3 differentiate already become 2. Okay, so let me just put brackets here, followed by another 2. Sorry, just want to be clear. Okay, I'll just delete this out. Okay, so this is where we differentiate power using power rule for the entire thing to the power 2.3. Then this thing, we differentiating sine 2 theta plus 3. This is where we differentiate our 2 theta plus 3. Okay, we could simplify it. We get 4.6 cosine 2 theta plus 3 sine 2 theta plus 3 whole thing 1.3. As in power 1.3. Okay, so I want us to be able to observe the difference. Okay, in this case, we do have the cosine, we do have the 4.6, but our cosine angle has a power of 2.3. Okay, this one has this extra part here, whereas this one we do have this side. So the derivative is definitely different. So the brackets really have a very huge impact, okay, about how we go about differentiating. Okay. Yep. Yes, please. Then next we look at 3b, where I want to differentiate cosine to the power of 4, okay, and the angle is 4x to the power of 4. We know that it is actually the same thing as cosine, angle, entire thing, power 4. Okay, so the process that we go about differentiating follows this same sequence. Power rule first, then after that slowly like an onion, okay, going inwards. Okay, so dy over dx will be bringing down the power minus 1. Okay, differentiate our cosine will give us negative sign. Angle will maintain with the sign. And then we differentiate the angle. Okay, then we simplify it. We would get 64x cubed cosine cubed 4x to the power of 4. 4 x cubed cosine cube 4x to the power 4 negative sine 4x to the power 4. I just want to reinforce certain notation. How do we use it? Okay, so I'm just intentionally letting gx equals to this. Okay, when we differentiate the notation that we will get g prime x itself. Okay, but before that, let us work around this expression. I could re-express it as this to the power of negative half. That will make our life slightly easier rather than to do quotient rule. Okay, if you do quotient rule, I think some of you actually tried it. You notice that it is algebraically tiring. Okay? And then you will probably get stuck somewhere. Okay, so in this case, when we apply our power rule, we bring this power down, negative half. Power minus 1, we will get power negative 3/2. And then we differentiate the sine square, 3x plus 7. So sine square is actually the same as considering sine 3x whole thing square. Okay, so therefore we can bring our power down to sine 3x to the power of 1. Okay, then after that, differentiate the sine, we will get cosine 3x. Differentiate the angle, 3x I will get 3. Okay, the 7 need not be differentiated. So this is the differentiation of sine square 3x. In particular, this is where we differentiate sine 3x. And this is where we differentiate 3x. Actually, it's not here today also. Is it? Right?
Just to make sure that you know that it's like bring the power down.
Okay, then after that 5c. Okay, we're given that hx equals to sine cosine x. So our cosine x is the angle for the sine. Okay, so it's a little bit of a lot of trigo within trigo. Okay, so to differentiate, which is h prime x. Okay, we do from the outside. So for our sine itself, upon differentiation, we will get cosine. Angle remains the same, so cosine x. Okay, so this is the differentiation of your sine, give us cosine. Angle maintains. Then we go about differentiating the cosine x inside. That will give us negative sine x. Okay, so by simplifying this, I'll just bring the negative to the front. Okay, so negative sine x. If you want, you can put brackets. Okay, and then cosine x. Do be very careful. Okay, cosine is a function, it is not algebra, so you cannot say that they are not equal, okay, to cosine square x. Cosine x is not the same as cosine square x. Okay, because cosine square x, we know that it refers to cosine x bracket square, which is cosine x times cosine x. Right? A bit like inception thinking over here. Yeah. 3D answer. Oh, okay. Because this one is a square root.
The answer is
Okay. Sorry, I forgot to simplify this. Cancel this. I will get negative 3 cosine 3x sine 3x over square root sine square 3x plus 7 to the power of 3. Is it like that?
why the
Okay. Don't make sense, I think I put everything. Yeah. Because power of 2 then put square root then simplify, no more, right? Yeah. I guess your textbook, this part not correct. Right? Yep. Okay. The textbook has an error. It should be 3. Doesn't make sense, it should be 2. Okay. And then, okay, last two, 5D and 5E. Given our y equals to cosine x plus 1 over x minus 1, there's no way to simplify the given expression. All we can only do is to later on apply our quotient rule when we want to differentiate this part. So for our cosine itself, when we differentiate, we'll get negative sign. Angle, keep it the same. Okay, and then we proceed with differentiating this by applying our quotient rule. That will be to keep the bottom, differentiate the top, minus away, keep the top, differentiate the bottom, and then bottom square. Okay, simplifying it. Okay, we have x minus 1 minus x minus 1. So it's a negative 2 from here. Negative gives us positive. So we can have 2 sine . Last one, 5E. Okay, we have sine x squared times cosine x plus pi. So we need to see it as a product of two things and apply our product rule. So dy over dx equals to, keeping the left side, differentiate the right, I will get negative sine x plus pi. Differentiating the x will give me just a 1, followed by keeping the right, differentiate the left. Differentiating sine will give me cosine, angle maintains. Then we differentiate our x squared, we will get 2x. Okay, so we simplify this. Here we get this. Okay. Any questions? Yeah? You want to put your skills to a test? No. Okay. I shall not force your then. Let me go off already, right? The four of you who needs to take your beautiful photos, here we go. I just want to complete 2 more questions on this topic before we can move on to the next one. Okay? Now, while we are learning how to differentiate trigo functions, okay, we are not void of learning how to apply this trigo differentiation into different contexts, such as your maxima, minima problems that we were looking at in chapter 14, and then also your tangent normal questions that we looked at in chapter 13, or even increasing, decreasing functions. Okay, so all those kind of topics that we learned in chapter 13 and 14, where we apply differentiation to different contexts, it will be extended, okay, when we learn our trigo functions or our logarithm, as well as our what's that called? Logarithm and exponential. Okay. So this will also require us to recall, okay, how to solve trigo equations that we learned last year. Alright, so let's take the journey back down the memory lane, okay? If that's how you call it. I'm not a very eloquent person, as you can see. Okay, so try 4, it says that a curve has this particular equation y equals to cosine x minus 2 sine x. Okay, part I requires us to find the value of x such that x falls within this interval here, and for which the curve has a stationary point. Okay, so this will mean that our dy over dx must be equals to 0. Okay, that will help us in terms of finding that value of x. Like I mentioned before, okay, our value of x usually when it comes to our calculus topics, when we do our differentiation and later on integration, it will usually always be in radian mode. Okay, so do change your calculator to radian mode for these topics. Okay, so with our y equals to cosine x minus 2 sine x, okay, our dy over dx will actually be equals to cosine differentiate become negative sine, minus away, sine will become cosine. Okay, so usually when it comes to differentiation of trigo, it is not as tiring as the whole series that I gave you all the other time. Okay, usually it's manageable one. Okay, so that one was really for us to practice. So dy over dx equals to negative sine x minus 2 cosine x. Okay, and we know that we're looking for a stationary point, so dy over dx must be equals to 0. And that means that we have to solve this trigo equation. Negative sine x minus 2 cosine x. Okay, how to solve this equation? That's the big question now. Okay, so when we solve a trigo equation, our basics is that we can only solve an equation when it is tangent something, cosine something, or sine something. Okay, so we need to get into our basic form. Basic form is just a word that I use. Okay, so maybe I'll use it. Okay, I can only solve a trigo equation that looks like that. Okay, so that means your angle itself, it can be any expression. It can be maybe 2 theta plus 3, 2 theta minus 1, 3 theta plus 5. Okay, just using this theta sign to represent some angle. It must be of this form. Then my next step of solving my trigo equation, okay, will actually be to find our basic angle. Right? So let's get to step 1 first. How do I even change this to get something like that? Okay, because I now have sine and cosine, I need a situation where I only have one trigo function. Okay, so what I will do is I can shift 1 to the right side, and then I'll have negative sine x equals to 2 cosine x. Okay, we know an identity that is sine over cosine gives us tangent. So what we can do over here is to divide, okay, by cosine x on both sides. Okay, why is it that we can divide by cosine x on both sides? That's because cosine x won't be equals to 0 in this case. Okay, so I will get negative tangent x equals to 2. Okay, and that's how we transform what we have into our basic form. In other words, tangent x equals to negative 2. So step 1 is done. Okay, so that's our trigo recap. Then we go into step 2, we need to find basic angle. Okay, so to find your basic angle, we do tangent inverse in this case of what? Of positive 2. Okay, we don't find the tangent inverse of negative 2. Why? Because trigo function of a basic angle, and basic angles are acute. Okay, your value will always be positive. Okay, so to find basic angle, must always take the positive value. Okay, because basic angles are pi over 2. Okay, so if you were to take tangent inverse negative 2, you may not get a acute angle. Okay, depending on what trigo function. Okay, so that's why we always take the inverse of the positive value, and it will definitely give us a positive value. Sorry, basic angle, acute angle. Sorry. So this in our calculator using radian mode will give us 1.1071. Okay. Then step 3, we go into finding quadrant or identifying quadrant. Okay, our ASTC. In this case, because we're looking at tangent x equals to negative 2, tangent being negative, it means that we're looking at second quadrant and fourth quadrant. Okay, the S quadrant and the C quadrant. Because this and this is where tangent is positive, down here tangent negative. Okay. So because we have identified the quadrant already, then I can find the angle. So in the second quadrant, okay, basic angle is over here, that's your alpha, but our angle theta, in this case it is x, x will actually be this entire angle here. So that's why we will always take 180 degrees minus away basic angle, and then I will get x. But in this case we're dealing radian, so 180 degrees refers to pi, minus away the basic angle 1.1071. This will get us second quadrant angle. Okay. Then fourth quadrant angle, looking at this, basic angle is over here. Okay. Your angle x is actually one whole round here like that. Okay. And then we will have 2 pi minus away the basic angle. In other words, 360 degrees minus basic angle. So 2 pi minus 1071. Okay? Questions? Anyone needs me to recap how we do this? Yes? Okay, okay. Never mind. I know this kind of things, always like that one. Okay? I do it the other side, huh? Just see what is this. Coming back to our trigo, okay, certain facts that you must know, okay, you must be able to recall, right? First thing, basic angles are always acute, that means less than 90 degrees, okay, or less than pi over 2. they are equivalent values. Okay, your radian and your degree. Okay, and it is always measured towards the x-axis. That means that, okay, if I have the angles in my different 4 quadrants, okay, be in the first quadrant, second quadrant, third quadrant, or fourth quadrant, in my first quadrant, where is the acute angle? It will always be towards the x-axis. Okay, it will be here. Okay, in my second quadrant, if I have an angle that lies inside here like that, my basic angle will always be here because towards the x-axis. Okay, the other one is here, and then the other one is here. Okay, this is where our basic angles are in the 4 quadrants. Okay, of course my lines is anyhow draw one. Okay, you can draw whatever size angle you have, but I just want us to know that basic angles are always towards the x-axis. Okay. Next, our angles are always measured in the anti-clockwise manner. Okay, from the positive x-axis. Positive x-axis refers to this one. So, if I draw another diagram, starting from here, if I have an angle over here, right? Okay, in my first quadrant, the angle that I'm looking at will actually be measured from the positive x-axis to this line. Okay? Whereas if it is a second quadrant angle over here, okay, the value, because it will be obtuse radius in our second quadrant, I will have to start from here, measure all the way here. Okay, that will be the angle. The angle that I'm referring to is the answer that we want to find. I'm not referring to basic angle. Okay, so second quadrant will actually be measured this way. And then in our third quadrant, if it lies somewhere like that, okay, start from here, measure in this cycle anti-clockwise, reaching the line. And then our final one, fourth quadrant, okay, starting from the positive x-axis, go one round all the way until we reach the line. Okay, so how do I find all these values that are indicated in purple, red, black, and blue? Okay, so let's say the purple one in the first quadrant. You will realize that if my line stops here, the angle that I have confirm will be the same size as my basic angle. So first quadrant is usually not a problem because first quadrant, same thing. Okay, the angle that we want to find is the same as my basic angle. The problem lies in our second quadrant, our second quadrant onwards. In our second quadrant angle, with this line over here to indicate the angle, okay, I'm measuring from here all the way to here. But I will always find my basic angle here first. So I will take 180 degrees, which is one entire semicircle, minus away the basic angle, then I will find out what is this value. Okay, so it's a little bit like piecing things together. Okay, because I will always find the basic angle first. Then, in my third quadrant, I'm going from here all the way to here. It goes 180 degrees plus the basic angle that I have over here. Okay, so I need to add basic angle, 180 to the basic angle. And finally, in our fourth quadrant, I will actually go one cycle like that, but it is a short of our basic angle, so taking 360 degrees minus away basic angle, and we will get fourth quadrant angle. So, to sum up what I just said, theta equals 180 degrees minus basic. Okay, so that's how we find the angle that we want to find. That is the x value. In this case, I'm just using theta. Okay, to help us find the second and fourth quadrant. That's why second quadrant in this case, I will take 180 degrees minus the basic angle. But instead of 180 degrees, I use pi because the question is in radians. Okay, whereas over here, fourth quadrant, I will take 360 degrees, in other words 2 pi minus the wave BCA. Okay? I can only sum up like that. Okay, I cannot be going back to cover your whole trigo, which you took one whole term to cover. Okay. So, okay, moving on from here, we can press our calculator, get the values. Okay, and we get 2.03 and 5.18. Okay, so these are the x values that will result in a stationary point. That answers the question already. Okay, but then in this question it says that it's from 0 to pi. Pi is 3.14 plus, so this exceeds already, so we reject 5.18. Any questions here? Right? Then, part 2, in the question they ask us to determine the nature of this stationary point. To determine the nature of the stationary point, we only have one x value, 2.03. And in earlier part, we already found the first derivative, that dy over dx is negative sine x minus 2 cosine x. Okay, so up to you whether you want to do first derivative test or second derivative test. To me, I will do second derivative test. Okay, because this one is manageable in differentiation. Differentiating sine will get cosine. And then differentiating cosine, I will get negative sine. Okay, so second derivative will be negative cosine x plus 2 sine x. At x equals to 2.03, our second derivative value, sub it in. So we use 2.0344, truncated 5SF value. We would get 2.2360, which is positive. And therefore, the stationary point is minimum. You all look extremely neat and burnt already. I only do one question today. Just now all that is things that we did last lesson one, you know. Okay. I think you all are really burnt by the solving trigo part. I assume that's the case. Okay. But this is where we really have to go back, to those maybe very dark times. I don't know. Okay. I hope that once you fix the light, it will become brighter lah. 13.1 question 15. Okay, once you overcome this trigo one, when you reach the exponential, you'll be very happy. Because differentiating exponential is the exact same thing. No need to use any grade one. Okay, differentiate e to the power of x is e to the power of x. But before that, let's look at this one. Okay, so in this question, we're given fx equals to sin x plus cosine x, and the interval of values is from 0 to pi. Okay, part I wants us to find the coordinates of all the turning points of the curve. Okay, so turning points will refer to your stationary points. That means our first derivative must be equals to 0. And we have cosine x minus sine x equals to 0. Okay. It is actually the same structure, okay, as just now. We just move one of the trigo to the other side, divide both sides by cosine, and I will be looking at solving tangent x equals to 1. Okay. X equals to 1. 1 is actually a special angle value. You can go and see that mini booklet I gave you. I did give a table on special angles. I think it is on page 4. Okay, the trigonometry 1. So tangent 45 degrees gives us 1. That's why our basic angle in this case is 45 degrees, and in other words, that is pi over 4. Okay. Right? Why am I keeping to exact values? It's because we are looking for coordinates. I thought it would be nicer if we leave it in exact. But let's also try to practice recognizing special angles. Okay. So if you cannot recognize special angles, okay, that means your 30, 45, and 60 degrees. Use your calculator in degree mode. Okay, when you press the inverse, tangent inverse of 1, okay, you will be able to get 45 degrees. Then just change it manually into radian mode. Okay, which will be 180 degrees divided by 4. So that's why it is pi divided by 4. Pi refers to 180 degrees. Okay. Right? From here, I want you to practice now. Okay, find the coordinates of the turning points. Determine the quadrants that I mentioned earlier on. Okay, in this case, what are the quadrants? We have tangent x equals to 1, which is positive. Determine which quadrants it is on. Find the two angles, and then after that, find out what is the eventual turning points. The angle refers to the x over here. The y coordinate you need to sub back in to find the y coordinate. Okay? Can I give you about 5 minutes to work on that? If you're still struggling in recalling anything, please let me know. I'll come to you. remember your quadrants repetition. Okay, I say one time Okay, in case you don't recall, tangent x equals to 1. 1 is positive in value. What does ASTC even mean? A means all positive, that means all your trigo is positive. S means sine positive, T means tangent positive, and then C means cosine positive. Okay, so because down here is tangent positive 1, that means it must be in our first quadrant and our third quadrant. Our second and fourth quadrant, tangents are actually negative. Alright, so therefore, our angles in this case should lie in first and your third quadrant. Okay? Okay, firstly, alright, in your formula booklet that I gave you, okay, on page 4, this is fine. Okay, on page 4 itself, you will see a special angle table. Okay, the special angle table, I only gave you the values in degrees. I want you to take note what is the equivalent in radian form. Okay, so you may just want to add it in. That 30 degrees is actually pi over 3, and then 45 degrees is pi over 4, 60 degrees is pi over... sorry, wrong. Wait. Sorry, my bad. Okay, this is pi over 6, this is pi over 3. Okay. Then after that, 90 degrees is pi over 2. Okay. My bad, sorry. Okay, but then of course you can press your calculator, 180 degrees divided by 6, you will get 30 degrees now. Okay, so these are the things definitely you must memorize. The table itself, okay, is just one way that you can help yourself to develop that pictorial memory. Okay, I really don't know what is it that you learned, okay, when you did your special angles last year. Okay, can I just do a quick check? You all learn by heart rule like that? Like memorize square root over 2. Okay, now I want all of us, okay, to learn this very fun thing that I learned over the years. Okay, we use our hand. Okay, so let's reach out our left hand. Okay, I think left hand will be good enough. Okay, so imagine, okay, our left hand. So I erase this table. So I want to help all of us remember, but of course, okay, let's not. I'm terrible at drawing, I told you already. Okay, this one, imagine left hand. Okay. Now, how do we use our left hand? Remember that everything must always divide by 2. Okay. You must remember your angles that each finger represents. 0 degree, 30 degree, 45 degree, 60 degree, 90 degrees. Okay. And now these are the exact rules of your left hand. Okay. So let's say I want to find sine 30 degrees. Okay, how? Sine 30 degrees, we close our index finger. Okay, sine we will read from the left side. How many fingers do we have? I count a thumb as a finger lah. Okay, let's not go into that philosophy aspect. There's only one. Okay, so it will be half. Right? Is it? Wait. Yeah. Half, right? Cannot be about 30 degrees. Yes, correct. Your heart that are scared, you know. Okay, yes. See that? One finger divided by 2. Correct? 30. So, half. Okay. Then let's try sine 45 degrees. What is it going to be? We close our middle finger. From the left, we have 2 fingers. So, it will be square root 2 over 2. Okay? So, actually, something else that I forgot. Everything must have a square root sign above it. Okay, so square root 1 is actually 1 lah. Okay, square root 2, alright, over 2. That's your sine 45 degrees. Correct or not? Your formula booklet also give that. Okay, then after that, sine 60 degrees. Okay, close this ring finger. 3 fingers, we will get square root 3 over 2. Okay, and alright. Then after that, I think usually we do 30, 45 and 60 only lah. Then cosine how? Okay? Cosine will be the other way round. We count from the other side. Okay? So, cosine 30 degrees, there are 3 fingers on the right. So, it's actually square root 3 over 2. Okay? Then, after that, your cosine 45 degrees got 2 fingers from the right, square root 2 over 2. And then cosine 60 degrees, square root 1 over 2. Okay? Can? Fun? Okay, but of course up to you how you want to memorize. Some people like to use calculator, some people want to memorize. Okay, some like to use your fingers. I just introduce all the suite of the skills, okay, to you for you to decide. Okay, so that's how we can remember. If you use your fingers, please be do it 光明正大啦. Okay, take out your hand and then show it. Okay, come in. Alright? Don't hide under the table, then later the examiner think you're doing something secretly. Okay, and then you're gonna caught for cheating. Okay, when you only trying to calculate your special angles. Alright? Okay, so but of course don't need to raise your hand and then show it to the examiner lah. Then they thinking that you don't know counting what your luck, whether you pass or not. Okay? Yes, but that's sorry. Your question? How about tangent? Good question. Okay, tangent. Okay, we know that Okay, so you just take sine, divide by cosine, or take the fraction, divide by the cosine fraction. Okay, or else, in fact, if I'm not wrong, right, it is actually square root 1 over square root 3. Sine 30 degrees is 1 finger over 3. So square root 1 over square root 3, 1 over root 3. Yeah. Okay. But I would rather just remember sine, tangent equals to sine divided by cosine. Just take the fraction divide. Okay? And now let's go back. Okay, 5 minutes left. Okay, solving this question. Okay, solve already, we get these two angles, first quadrant and your third quadrant. Okay, then after we find the y value, some of you make the careless mistake of substituting into the first derivative, which clearly should be 0, but we should substitute into the given function. Okay, we get root 2 and negative root 2. Alright, then, okay, why did Miss Pang do the second derivative test? It is because in this question, it said coordinates of the turning points. Turning points only refer to two things, maximum or minimum. So I need to go about verifying that my points are indeed a turning point. Okay? At this juncture, I can only tell you that you can only know that pi over 4 and root 2 and 5 pi over 4 and negative root 2. These 2 points are stationary points based on the calculations that we have. I still have not yet verified that they are going to be turning points. Because if they are points of inflection, then it is no longer a turning point. Okay, so that's why I do my second derivative test, or if you want to, you can do your first derivative test. Okay, and you determine whether are they minimum or maximum to conclude that it is going to be a turning point. Okay, so that is the catch in this question. Questions? Okay, I think let's not do part 4 okay, today. Right, I think our brain will burst because part 2 will require our recollection of trigo graphs. Okay, a little bit of recollection of our trigo graphs. So today we have covered, okay, we recall how to solve trigo equation and also how to learn how to do our special angles. Okay, so next lesson, that will be next week, then we will go into our trigo graph recap. Okay. You want me to give your homework first? Yes, no? Yes? For 15.1 Okay, I just assign first that you want to do, you do, okay? If you want to wait, then you'll wait until the closer deadline. I'll give you a longer deadline, okay? Actually, I want to give you another set of practice, okay? But I think you all will curse me, alright? So, I think I'll also mark until I will die. And I'll answer your question when I collect your homework until I will die. Okay, so let's keep this simple. Let's just do question 7, 10, 13, and 16. Okay? Question 7, 10, 13, and 16. Okay? Let's do this. Let this be due by next Thursday, shall we? Okay? Due by next Thursday. Okay, so tomorrow home-based learning will be on matrices. Complete the worksheet as you do the lesson. And complete the SLS by Wednesday midnight.